What about beneficial mutations? Do beneficial mutations exist? Do they happen? Careful. This is a trick question. The answer is, it depends. It depends on what we mean by beneficial, and it even depends on what we mean by mutations. So let's back up. In the last video, I explained how natural selection is a real thing, but would be more correctly called attrition in the context of evolution. Natural attrition happens, but this doesn't build anything, and nobody is selecting anything. Misunderstanding words can be dangerous and often very confusing when it comes to the claims of Darwinian evolution. So let's stop and think carefully. How is evolution supposed to work anyway? The mechanism is basically for serendipitous variations or mutations, the beneficial ones, to be singled out and preserved by natural selection over long periods of time. Anyway, that's the claim. I've already made the point that preservation doesn't happen at all. There is no such thing actually. It is attrition or culling that happens naturally, not preservation. So if organisms have successfully built genes, they would have to be coming from a different source besides attrition. But even if preservation was real, which it isn't, what exactly is supposedly being preserved by this model? Well, let's look at that. Remember that genetic information in living things is stored in long strings of digital code. This is what DNA is. The DNA molecule looks like a twisted ladder, and each rung of that ladder consists of a pair of what's called nucleobases. Bases may be A, C, T, or G. Everyone has seen diagrams of DNA, but we often forget that in such diagrams, we were only looking at a small chunk of the whole thing. In human DNA, this twisted ladder is 3 billion, with a B rungs, long. If it were not wound up, but pulled out straight, human DNA molecules would be 6 feet long, and each cell contains one of these things. Onions actually have longer DNA molecules than humans, and the DNA in all living things, in each of our cells, use the very same chemistry. Basically, the only reason we are humans, instead of onions, is because the order of our base pair sequence is different. So what happens if the sequence of those 4 base types gets shuffled, or scrambled, or misspelled? That would be the thing we call mutation. Mutations are random alterations of the sequence of this genetic coding, this genetic software. Mutations can be thought of as genetic accidents or genetic damage. Okay, so that's what mutations are. What about the word beneficial we talked about at the beginning of this video? Well, consider your own computer. If the software code made of strings of ones and zeros in your computer gets scrambled, what happens to the operation of your computer? It's not good, is it? So is random tampering of complex integrated code ever a good thing? Actually, in rare cases, it can be. But here's what I mean. If Hitler's car got into an accident and got totaled, wouldn't that be a beneficial accident? From the perspective of the Allies in World War II, it sure would be. Or what if damage happened to a gene in certain bacteria? Here's the setup. In a number of examples, there is a functional gene in the DNA of these one-celled bacteria, which, when the gene is working properly, functions to open gates in the cell wall that allow particular molecules inside, including antibiotic molecules. But let's say that important gene in the bacterium gets broken and stops working. What happens then? Well, the cell wall gate stays closed, and the antibiotic molecules can't get inside. If they can't get inside, they can't poison the bacteria, and the bacteria stay alive. So in this case, are mutations beneficial? We have to ask, beneficial for who? This particular mutation is beneficial for the bacteria, but harmful to the gene being broken, not to mention to the patient. You see, the word beneficial is a matter of perspective, isn't it? The mutation is situationally beneficial to the bacteria, but informationally it's harmful and damaging. The genetic information is thus corrupted. There are many more examples of this idea. Polar bears are actually genetically degraded brown bears. Friendly dogs are genetically degraded vicious gray wolves. The sickle cell mutation damages blood cells so badly that even malaria protists don't like them, and people are prevented from getting malaria as a result. We like polar bears, we like dogs, and we like not getting malaria. But in each of these cases, there is informational damage, even if we view it as a benefit in some other sense. So, the phrase beneficial mutation is ambiguous and very tricky. It depends on the particular perspective. In these rare cases, mutations are beneficial in a situational sense. But if our consideration is the information content of the genetic code, mutations are always harmful. Always. No exceptions. Now, how do we know this? Okay, let's take a closer look at the nature of information with a few examples. Basically, information is a low entropy, low probability, symbolic message arranged against a high entropy, randomized background to remove ambiguity of meaning. So spattered ink on white pages has no content, but very particular arrangements of that same ink on that same paper can hold enormous information content so long as it follows predetermined syntax rules in a predetermined language, but randomness is the enemy of information. Extraordinarily low probability arrangements are of its essence. So, if you wanted to write a novel or instruction manual, would you dump out a barrel of Scrabble letters on the floor and hope for meaningful sentences to form? Of course not. Or, suppose you already had a novel or instruction manual spelled out with Scrabble letters on the floor. Would you expect that you could stir bits of it with a stick and ever get new content to be added to your book? What if you are a software engineer? Could you ever write a computer program by moving a powerful magnet alongside your hard drive, hoping for the best? Once again, the answer is an obvious no. It doesn't matter how many iterations you go through or how many billions of years you carry out such a trial and error approach to producing information. It can't ever happen because the very definition of information is the opposite of randomness. In fact, Merriam-Webster's dictionary defines random as having no specific purpose or function. Information is exactly that, purposeful or functional. So would you throw a bomb at a building to construct a new kitchen? Or add lead weights to a glider to make it fly better? Just so, information and random mutations are a contradiction in terms. They mean the opposite of each other. To think otherwise is so wrong-headed it borders on insanity. For this reason, I'd say that evolutionists have lost touch with reality while claiming to be scientists. Here are our takeaways. Once in a long while, mutations can indeed be situationally beneficial. However, mutations are always informationally harmful, always, no exceptions. Now let's think about this for a moment. If mutations are always informationally harmful, then how could information arise at all? If no intelligent agent was involved, how could information write itself or program itself? How could microbes ever become microbiologists, Mutations do not build information. They destroy information,